One approach to question 11 is by trial and error. Looking at the 5 options given, f of x equals x squared seems to be the simplest option for which we could check the truth of the statement given. In other words, could it be that x squared minus y squared equals y minus x by xy squared? Looking at that, you can quickly see that the left-hand side will have at most indices of 2, whilst the right-hand side will have indices of 3. So clearly A is not the answer. By similar logic, B seems unlikely to be the answer, as the indices are unlikely to match. C doesn't look too appealing, so D is worth investigating. Using the function f of x equals 1 on x, we have 1 on x minus 1 on y equals y minus x by 1 on xy. And you can see that if expanded, that would give us y on xy minus x on xy, which is going to be true. So our answer is D. Another approach to this question would be to use the judge command on the ClassPad. To do so, first of all, we need to define our function. So let's start with our option of x squared. Okay, so now our function's defined. We can call up the judge command. I'll get that from the catalogue under J, and we can put in our function expression. I'm going to use the ABC keyboard to do this. The judge command returns a response of undefined for the function f of x equals x squared. This is indicating that that statement is true for some values of x and y. Going back and altering our defined function, we can try our next alternative, which was our 1 on x. And this time judge returns the output true, indicating that that statement is true for the function given, confirming answer D. Question 12 asks us to find a function using a series of transformations. Firstly, we are told about a reflection in the x-axis. That means that y maps to minus y. So our function will look like f of x equals minus square root something. That means that we know our rule is either B, D, or E. But which one? The next transformation we're told about is a dilation from the y-axis, factor of half. That means that x becomes 2x, so our rule becomes 2 by 2x minus 5, and from that we can see that the answer must be D. In question 13, we're asked to find the area between two functions. It looks like this could be found by finding the area between f of x and the x-axis and subtracting the area between g of x and the x-axis. The area between f of x from 0 to d will be the integral from 0 to d of f of x dx. And the white area, the area between g of x and the x-axis, is from a to c, so we'll subtract the integral from a to c of g of x dx. Now, how does that relate to the answers provided? Well, that's answer E. Question 14 asks us to maximise the area of this rectangle. The rectangle has dimensions u by 4 take u squared. So we need to maximise that expression. We can do that on our ClassPad. First we'll enter the expression. Now we'll select it. Open the Fmax command. And we'll make sure our variable is also u. And we'll set our domain between 0 and 2. And we see the maximum value is 16 root 3 over 9. Looking at the answers provided, that's answer E. In question 15, the probability required can be calculated as follows. The probability of getting 2 marbles of the same colour is equivalent to the probability of getting a red first, followed by another red, plus probability of getting a blue first, multiplied by the probability of getting another blue. And that has a value of 7/15, so our answer is C.